Hello, everyone. Welcome to this Toronto Machine Learning Micro Summit in Retail. My name is Nadia, and I work at NILAS as a senior machine learning engineer. Today, I'm honored to be here and to have the opportunity to introduce one of our amazing speakers. Before starting, I would like to remind you that if you have a question, please post it in the chat. I will collect all the questions and ask them directly to our speaker at the end of the presentation. So our speaker of today is Rogayeh Tabrizi. Rogayeh is the co-founder and CEO of data science firm Theory+Practice that specializes in bringing advanced AI solutions to the financial service and retail industries. She received her master's degrees in experimental practice physics at Simon Fraser University and worked on the Atlas detector at CERN in Geneva. She earned her Ph.D. in economics and became fascinated with game theory and the behavioral pattern in social networks. She spent extensive time at the economics department at Stanford University, studying with renowned economist Professor Matthew Jackson. With a physicist approach to uncovering hidden trends and indicators in big data, coupled with a microeconomics focus on behavioral economy, game theory, and social and economic networks, Rogayeh is uniquely skilled to explore how organizations can create true value from their data. In addition to her extensive technical background, she has over 10 years of experience working with financial retail and logistics companies to help them utilize insight from their data and create a measurable path to data efficiency and subsequent exponential value for her clients. She is an active member of the Forbes Technology Council, the recipient of 2020 Women of Influence One of Watch Award, and was listed in the top 40 under 40 by BIV. Please join me in welcoming Rogayeh Tabrizi.
Thank you so much, Nadia. I want to make a joke. I want to say I want to take you to every one of my meetings. Thank you so much for that introduction. I really appreciate being here, and I'm very excited about talking about one of the topics that's very close to my heart. So what I'm going to do, I'm going to go ahead and share my screen, and we'll just take it from there. And yes, please put questions in the chat, and happy to get into a discussion at the end. All right, so give me a minute. All right, here we go. And how about we don't just start with the end of the presentation? Okay, let me just put it in full present mode. All right, so in this talk, I want to talk about some of the most common use cases and conversations that I usually have with retail executives. One of the things I think it's given our background sitting at the intersection of algorithms, data, but also really caring about behavioral economics and, being able to benefit from the micro signals that you can actually extract from data and how to use it effectively. Like that puts us in a unique position. So, but before jumping into the use cases and some of these common questions, let me talk a minute about why retail and why now. Customer-centric industry, a lot of data, almost nobody knows what to do with. There's just so much, sky is the limit in terms of the possibilities of what we can do by trying to understand customers' intents, preferences, behaviors better, trying to move toward personalization, hyper-personalization use cases, but also really benefit from using very much the same kind of data, but creating efficiencies on the operations, on the inventory management, and there are a whole bunch of different use cases that we can get into. A lot of executives are really, voting on the fact that AI can increase a lot of benefits for them by just the amount of dollars that's going into AI opportunities. These are some of the facts that I have just highlighted here. Some of the most impactful use cases that right now executives are focusing on are most related to personalization use cases, again, thinking about pricing a strategy, promotions, markdowns, and those are some of the use cases that come up and again can very much increase efficiencies and revenues in retail. Well, with that, here I just wanted to, at a very high level, highlight some of these different use cases. So you have, use cases from very much at the, at every single different interaction point with the customer journey, around customer acquisition, customer retentions, around creating 360 views of customers, the omni-channel and commerce component of it. You can move toward store operations, product lifecycle, even designing new products, but definitely on the inventory and merchandising. There are logistics use cases, very interesting use cases, especially during COVID, that a lot of retailers and grocery stores have moved toward delivering. So there are a lot of very interesting use cases in logistics these days as well. And of course, like real estate and identifying what are the best locations for stores. Although during COVID and because of COVID, the future of retail stores probably has been disrupted forever. But anyways, I feel like it's too soon to say something like that. Okay, let's move on to considering what would be an appropriate approach for retailers to consider if, especially, they are focusing on bringing AI and insights. Some of the work that we have done has really sat on that intersection of blending microeconomics, behavioral economics with solutions in AI that are actually scalable. And there's a piece that I really want to highlight because I think it's very, people don't really talk about it that much, and that's the intellectual diversity. If you're just going toward AI from a computer scientist or even a physicist perspective, the odds are we're going to miss one of the most important ingredients, which is the to what end of our algorithms. So with that, these are some of the top use cases, and I won't be lying to you guys if I say maybe on a weekly basis, I would have several of these conversations around these questions with the clients and prospects that we sit in front of. Some of them is very much related to customer journey and intent, especially around dynamic journey mapping. But well, if you really want to move toward dynamic journey mapping, you have to start with a question, which is, do we actually understand customers' intent and preferences in any given moment in time, so that based on that, we can move toward a dynamic understanding of our journeys, our customers' journeys. If we understand the intentions and the preferences, how do we go around identifying the drivers behind some of these predictions that we have, right? And what are some of the most appropriate interventions for each one of these different moments, given different preferences, given different intentions? So from there, some of the questions that also have been highlighted, especially during COVID, was questions around return and predicting returns. So can we actually predict who is going to return what item before customers actually purchase it online? And if we manage to do this, well, the short answer is yes, you can do that. And if we manage to do this, what are we going to do with that information? At the end of the day, that's just piece of the puzzle. Probability of return is just piece of the puzzle. You need to ask yourself, what is it to what end? What am I going to do with that information? Maybe we can give some discounts and make a sale, final sale. But is that really the best thing that we can do? What are the unintended consequences of putting promotions and discounts at any one of these intersections? Are we going to encourage discount shopping behavior, which is not necessarily ideal? So it just goes, there's more to answering these questions and what we actually are going to do in order for them to be truly valuable for our organizations. And of course, the next piece that I don't think is a surprise to anybody is around creating a 360 view, a single view of the customers. Can we really try to hit several birds with one stone? Do we really need to treat data in different silos? We talk about customers and customer journey, intent, product design, upsell, cross-sell, bundling, all of these things, but are they really different from the inventory side of the house? Of course not. They're not really different or separate from, what you would need in order to predict prices or, come up with like personalized demands and stuff like that. Anyway, so there's again the theme throughout this presentation is going to be the focus on we really can have a different approach toward data. We can go to data that much more targeted and answer several questions perhaps at the same time. All right. So for the rest of this presentation, I do want to focus on the customer journey and intent and the piece that is related to the to what end, which is the intelligent intervention piece. But so these are some of the conversations literally from one of our clients. Last year during COVID, again, we worked with one of the biggest retailers, Fortune 10 company. They're all over the world. And really, sky is the limit in terms of the kind of data that they have had over so many years. So the question to us was, we really want to understand customer intent and the journey path. What are the key moments that actually trigger a journey? What are the net new signals that you can actually extract from different complicated journeys? And can you actually separate customers from shoppers? And in that lies the notion of loyalty. Well, why do we want to do any of these things? Of course, share of wallet, building trust, removing cognitive load. But one thing that they kept talking about also was creating delight. They did realize that especially in the absolutely competitive environment they're living in, there needs to be a very real differentiator that is based on trust. But again, I'm a data scientist. So when you tell me something like, well, how can I build trust? The first question at the back of my mind is like, what are the net new signals? What are the signals that are going to actually tell me that, yes, here is an opportunity for building trust and loyalty? So how can we actually leverage this? So I guess what I'm really trying for you guys to get out of this conversation is, or I guess like it's a talk, is that giving the scores, numbers, all of these things only going to take us so far. We really need to understand the why behind the numbers, the why behind the scores. And that's the piece that is actually actionable. All right, so some of the determining objectives, some of the actual what's that we went after in this particular instant, we said, okay, let's go to data to try to characterize customer intent in the context of completing an online session. Why did we even go after a question like this? Why an online session? And why do we even care about the session being completed? Well, if we actually understand what are the factors that contribute to a session, and I'm not just talking about cart abandonment, I'm talking about any session that you have when you're on your phone or on your laptop and doing an online grocery order, right? So what happens that although you have put a bunch of items in your basket, you end up not completing that order, right? That you end up not completing that session. We wanted to understand the why behind it and the main drivers behind the observed behaviors as well as the outcomes that we were interested in. And the whole point of it was that if we manage to identify why people actually drop a session and just, not continue what they were doing, whether it was just, looking at different colors, different sizes, maybe putting different items, or actually completing the purchase, if we manage to understand the reasons behind it and the moments that those things are actually being triggered, then we can put interventions in front of them. For us, it wasn't really about just building a recommendation system or, just putting prices or giving a discount or, promotion popping up or something like that. The whole idea was to understand what is the driver of the behavior, what is the most important factor, and then put the right intervention at the right time in front of people. So that to me is the pinnacle of hyper-personalization. So in order to do this, I'm going to talk about the roadmap that we walked our clients through in 3 main steps. So most important piece at the beginning, at least, was the identification. Can we actually quantify the risk and then identify the drivers behind that risk? Based on the drivers, can we actually now go build hypotheses and test those hypotheses? And then based on that, create a system that automates the decisioning component of it. So I'm going to take a few minutes and talk about the identification model. So we did 2 different things. The most important piece that we wanted to do was, again, implement a model that assesses the probability of any session being converted or abandoned based on the behaviors and based on really the micro behaviors. What we ended up doing was building a transformer. Transformers come from NLP, extremely useful algorithms. I'm happy to talk about a little bit more detail. Some of the inputs that went into this transformer was session activity and the contextual information about the products and items. And the output was probability of a session being abandoned. Here you see I'm coming back to the intention signal. you know, one of the most important thing again was being able to get to the micro behavior level so that we identify or just be able to say something a little bit more meaningful about customers and shoppers' intentions. And this is actually one of the main reasons we ended up going after a more complicated algorithm. Although even feasibility of deploying the algorithm at the moment that we were suggesting, it was a big question mark because of the considerations around latency time. It's a neural net. It's going to take more time. We had latency requirements of about 500 milliseconds. Really, we are in the land of XGBoost with those sort of hard requirements. So, but one of the things, again, was you don't need to fire a model like this at every given click or at every given instance within a session. There's more you can do with this, but let me walk you guys through it step by step. Well, the idea was build a neural net, build a transformer that is going to predict probability of a session being dropped out. Next step right after that was now let's take the output from that model and project it into a lower dimensional state, which is this our driver identification model, which is a lower dimensional model. It's an XGBoost. And on top of an XGBoost, you can run a Shapley, which is going to give you the drivers of, the drivers behind some of the predictions that we would see. Why did we actually go even after an approach like this, after like a double approach like this? An algorithm like transformer, it would benefit from two main components. Transformers, some of you guys are more familiar with the NLP algorithms, probably have come across these models. When you have a sentence, and so here I have a sentence, transformer model is able to build explicitly blah, blah, blah. So let's say a few of these words were dropped, and you would feed the beginning of a sentence to a transformer, and the job of the transformer is actually predict what is the next word that would come up, right? Well, what does it really happen? So the context and each one of these words matter, but the other thing that is actually also really important is the sequence of words matter. A lot of the algorithms that we have, especially recommendation type models that we have, they usually very much benefit from the cross-sectional component of the data. It would compare a whole bunch of different individuals and different purchases over time, and it would just say, okay, you're also likely to purchase this other thing. So very much a cross-sectional dimension. There are, of course, recommendation models that enter the time dimension into the picture. There are more Markov type models, but they have very short history. This happened yesterday, then something else is going to happen tomorrow. But what we needed, because within a session, we really care about, you put this item in your basket first, then you went and checked the size or the color of something else, then you came and just did something else. So the sequence of activities actually matter in order to predict who is going to actually drop out of a session. So we needed an algorithm that not only takes into account the cross-sectional component, but it also takes into account the time series component as well. So that's why really we went after a transformer. They're really, they're very interesting models, can give you a lot of micro signals. The body of the algorithm can learn from a lot of behaviors over time. But the drawback, obviously, is lack of interpretability. It's really hard to run a Shapley on a transformer. So what we needed to do was to project this higher dimensional model into a lower dimensional model. So map the risk score into a reason space. So what we ended, and that's really behind the reason behind the XGBoost model at the end. Let me take a minute. I'm going to talk a little bit more about the algorithms in a second again, but let me take a minute and talk about what I mean by minimum viable data and what was the kind of data that actually was fed into these different algorithms. So session activity, we had Google Analytics. So we had a lot of very rich activity data in a session. Then we had, of course, contextual information about the products. We had all the names of the products and items and the hierarchy, different departments, pricing information, etc. Pricing was a little bit more tricky, but I'm not going to get into that. And, when you think about it, did we have access to other data in terms of promotions, discounts? Yes, we had all of that. But did we really need all of that in order to predict what we are going after? sure, it can improve the situation, but how much, right? So the idea was that can we start with a targeted set of data to prove to ourselves that it's actually going to work? And that's what we really mean by the concept of minimum viable data, so that we can build our minimum viable models. So the risk quantification model, the idea was, as I just talked about, we wanted to go build a risk score. We used the transformer model, and it was fun. The precision that we actually got was around 75% at a recall of 50. This is, you may think this is a low precision or high precision, but it actually was for this kind of model and this kind of environment actually is a pretty good performance. We know of other models in similar environments that hit literally precision of only 20%. So we were pleased when we hit this. And then moving to the driver identification. Now, once we had the risk score, again, the idea was to use features, just a standard feature engineering that we would do in order to build an XGBoost, and then try to predict. Now, our target was actually predicting the risk score that had came out of the transformer model. In order to do that, we used two different XGBoosts. One of them was a regression-based, one of them was classification. In the regression-based model, you have continuous variables. In a classification, you have zeros and ones. That's the main distinction. But I think the important piece is the 23 features that we end up building that were based on the session activities, the basket composition, products, etc., and the pricing information. So this is what I mean by projecting a high-dimensional model into lower dimensions. We built a model, gave us a risk score. It took into account all different kind of activities, right? Then we take the risk score and we said, out of these things that are actionable for us, and what I mean by these things are these 23 features that are based on the stuff that happened actually in a session that we can activate on. How does now these variables predict that risk score? So the models worked fine. We hit a precision of about 80%, recall of about 80% as well for our regression model. That was the model we used. And then baseline model was also similar performance. But later, that are more expensive, they're going to reduce probability of purchase. Well, that's what we didn't see any evidence for it. As a matter of fact, the pieces that were most important were a number of.
It seems Rogayeh is having some technical issues, so let's see if she's coming back.
I'm so sorry, guys. My entire internet dropped at the office. Here I am. Have we jumped right back into it?
Yeah, so we have in the chat, Nadia asked others to indicate where you dropped off so you can continue. And sure. The other thing is, I know you covered a lot. Maybe we can take a second to answer some of the questions.
I would love
seeing that this is a longer presentation so that we don't get we don't have to drag back too far. But anyways, I'll let you continue. Thank you.
Let's do it.
Okay, so we do have two questions so far. So I'll start with these two questions before starting again with the presentation. Actually, the first question, it's a two-part question. So the first part says, what tools do you use to access the minimum viable data set you created in the Google Analytics, BigQuery plus scripting or something else?
That's actually a great question. We have done a whole bunch of trials under the sun that you can imagine, working with a lot of different clients. One of the things that we are using right now is dbt. If you guys don't know about dbt, it's a brilliant tool that helps you combine Python and SQL. And we have used dbt in order to automate most of our data profiling exercise. In order to identify the minimum viable data, the most important piece of it is, you usually start with 200, 300 different data sets, and the job is to come down to those 19, 20 data sets that are going to have the most important pieces that we are interested in, right? So in order to do that, quality of data in each one of these data sets really matter, what is available. So we do a lot of work around, well, first of all, just knowing the basics. What are the variables that you have, like min, max, and which one of them are clustered at 99.6, and all of those sort of standard things. And then from there, you have to figure out how you're going to actually rank your variables and in terms of the importance. So we do a lot of work in terms of just literally 500 plots in front of us, just looking at it, looking at distribution of things and seeing which variables are better proxies for what. So it's a very important piece of work. Unfortunately, most of the time people skip it. It's much easier to throw all of your variables into, especially if you're building a neural net, throw it all into a neural net, and then God knows what's going to come out of it. Definitely not recommending that. But if you take time to profile the data, to really understand what is in your what is in the database that you're working with, it's going to serve a much longer path.
Okay, thank you so much. Yes, so you usually need to spend a lot of time finding out how much information your data brings to the model. Otherwise, yeah, it's time wasted. Okay, second part.
Example, we just the last thing I would say on that, we usually spend at least a month on just profiling the data.
Okay, so second part of the same question, did you use out-of-the-box GA tracking, or if not, what did you set up your customer event taxonomy?
The data sets that we worked with, I mean, this organization is literally one of the 2 biggest retailers in the world. So they have a very solid lab. They have very solid databases and data systems. There are a lot of work that has already been done working with Google Analytics, Adobe Analytics, we all know that it's like, you're usually working with 1,200, 1,500 variables. So to bring that down, we end up working with about 150 different variables out of that. And there were connectors and primary keys that we could actually connect it back to our transaction data. And we could also connect customers that have come in the morning, then didn't do anything, 2 days later came back, or maybe in the afternoon came back. So we could actually connect a whole bunch of these data points to each other.
Oh, that's so cool. Okay, next question. It is possible to build this with a scikit-learn only, or I'll need Amazon ML solution, for example?
Okay, how am I going to answer this question? We usually build most of our algorithms from scratch. So I'm not necessarily the best person to be like, hey, do this and do that with some of these already available packages. The reason behind it is some of the questions that we are going after are you really have to bring a whole bunch of different pieces from different places. So we usually build our own implementation of some of these more complicated models. We build them in TensorFlow or sometimes PyCharm and stuff like that. So that's all I can say on that one. I really encourage people to try to understand the mathematics behind some of these models. I mean, there are a lot of tools and a lot of already available packages. If you really want the work to be impactful, we need to understand what kind of mathematics also goes into some of these models.
Yeah, that's true. I agree. Okay, next question. I assume the model APIs is using streaming data to calculate probability of session completion or incompletion. When is the risk score recalculated within each session? Is it with each new event streaming from customer session? If so, was scalability of the model difficult to achieve? This is a really long question. If you want, I can split it in part.
No, it's a very good question. I know exactly what they're talking about. So I was going to mention this. I think I got rid of the graphs that I had related to this particular question. But here's the beauty of a model like this. We actually showed that just around minute 3 in a session that is about half an hour, the model stabilizes. So even if you just use more information from the rest of the session, which we did, the prediction is not necessarily going to improve. So which is actually quite powerful, because that basically means the first 3-4 minutes of the customer's work or the customer's interaction in that session is going to tell me what's going to happen in the rest of the session. And that's exactly the point of the intelligent intervention. If I know in very few early minutes of a session what the session is going to turn into, I can come up with interventions early on. There are a few examples. If you hold on to that question, I'm gonna give 1 or 2 examples related to that.
Oh, that would be really interesting. I'm really curious to see now.
Sure.
Okay, then what do we have? from what I'm seeing on your slides, it seems like the precision recall on the driver identification model is higher than the transformer model. Am I understanding these slides correctly?
Yeah, that's actually correct. And the reason behind it is the stuff that went into the transformer are more than the 23 features that went into the XGBoost. So, and we were totally expecting that. We weren't surprised at all by seeing that performance. And again, the transformer, the fact that we even hit that kind of performance was in itself very promising. Really, the whole point of it is why did we build the transformer? We wanted to not make assumptions in advance. I didn't want to say, oh, we think number of add to carts, we think price, we think this, we think these different features are the things that are going to tell us risk or anything about risk. We did that as a matter of fact. But the thing that we wanted to say was that here's everything in a session, feed it to the to transformer, tell me the risk. And I know I can't interpret it. I know which one of these things were more important, but at least I know that the risk score has been derived based on the entire interaction of an individual within a session. And then from there, now I really care about the actionable components. I want to know if diversity of the basket is important, number of super departments that I visit is important, number of add to carts is important, is price important, is the correlation between this and that important, right? And those are the things that we fed into the XGBoost. And we actually, the one that we end up using was a regression model because we wanted to treat the risk score as a continuous variable and not just as a 0-1. So the regression model, and that was, I mean, we did the basic one and then the classification one, and then we used the regression-based model that for us, it just made more sense to go that way. And I see a question about weather. We did consider putting information about weather. We didn't get it in time. That would have been interesting. One of the things, the proxy for it that we put in there, we had timing and we had seasonality. So, I mean, that's an interesting one, and we had a lot of discussion around it. But yeah, we didn't have the data.
Oh, that's cool. Correlating, try to see if there is a relation between weather and if people is gonna buy or not. That's really
for sure.
Okay,
for sure.
I see the last question. Then maybe
Sure.
we can go back to the presentation. So thinking about the product, you first have a risk score for abandonment and then a reason coming from XGBoost. You then customize the intervention based off the reason, correct?
Partially correct. The first 2 points, totally correct. The third piece about the intervention, the objective function that you want to use in order to, so, okay, let me back up. So you have your models that are giving you signals. Those signals are the risk score and the reasons behind that risk score. So now you basically have to take that and feed that information into another model that is telling you which one of these interventions is going to maximize the KPI that I'm interested in. If the KPI that I'm interested in is share of wallet, or some sort of maximizing click-through, or anything related to the customer and customer metrics, those are basically you basically deal with a constraint optimization problem in order to identify which one of the interventions is going to be most impactful. So it's almost a 3-step. But the piece about it, and the reason I keep using the language of hypotheses, is that experimentation is built by design into a process like this. Because I have my risk score, I have the drivers behind risk, I have the set of interventions that I have some hypotheses around, and all of that has to go into this optimization thing. And what comes out of optimization, you get to observe. Not only you observe the behavior, but you also observe the outcome from these models. And based on the observed outcome, you actually see, was that recommendation system that you thought to put in place actually did its job, right? Or that price discount or promotion that you did.
Cool. Thank you so much. Yeah, thank you so much for a very detailed explanation. Okay, we just got another question. Do we want to go? Sure. Okay. How were the embedding for sequence input into the transformer training?
That's going to take us in a very technical direction. Javad, happy to talk about it, but I think what would be best if you just like sent me a note, and we can just get into that, because that's a pretty technical piece. But yeah, there are ways of actually creating these embeddings based on the session. It was a lot of fun, but it's not something common. It's not something that people do. But yeah, definitely reach out, and happy to connect you and answer the question in detail. But the idea that you have is actually correct. Each event, each action within a session becomes, it's like a word in a sentence. So it's a word, and then you just consider the sequence of these words. But yeah, let me just leave it at that.
Yeah, that's a pretty good hint. If you know transformers, how they work. So yes, that's a pretty good hint.
Let me share my screen. I want to show some of those examples. And I think that was weird just about the place that I actually cut off. So let me try to do this again. Okay. All right, so you guys see my screen?
Yes,
perfect.
We can see your screen.
All right, so hypotheses. So I just showed you guys, and I mentioned that add to carts, number of super departments, number of unique items. These were some of the main drivers that came out of this, this study. But so let me tell you guys first what you're looking at. So on the y-axis here, you have the number of unique add to carts. On the x-axis, you have the number of super departments. The scale here, the dark blue, basically is our risk score, is the probability of conversion being 1. And but you see, I'm just treating it as a continuous variable because we use the XGBoost regression, and 0 is basically probability of dropping out. So with probability here, 0 means people drop out, 1 is that people actually stay. So look at this distribution here. Number of add to carts, when you have spent the time to put actually more items in your basket, you are, so as we are going up here, you're more likely to actually finish that session. But look at this first line, right? So if I'm just looking at one super department, a super department is like, I'm just in groceries and I'm just in dairy products, let's say, or I'm just like looking at fruits and produce or something like that, right? So if I'm just looking at 1 or 2 super departments, even if I have put like 30 items in my basket, the odds are I'm not going to finish that. But when the number of super departments, number of different items from different places that you put together, so together, these 2 variables together predict conversion, basically. And so here, an actionable component, if we actually know diversity matters, so maybe in minute 4 and minute 5 in a session, instead of putting a substitution-based recommendation model, we put a complementarity-based recommendation model. If I have bought an organic banana, if I have put an organic banana in my basket, maybe now you want to recommend an organic yogurt to me instead of another fruit. Or if I'm putting yogurt in my basket, maybe you don't want to just like, show me milk because it's the very same department, but maybe you want to show me just, I don't know, something about cleaning supplies or something like that, right? It's about complementarity. This basically what you want to see from this is complementarity matters. And it's not just about the number of unique add to carts that I have done. And exactly in the same way, if I am like looking at like 13 different super departments and I've only put like 1 or 2 or 3 items in my basket, the odds are that session is also not going to convert. That basically means your website is not really doing a great job in getting me toward the items that I want, right? So down here, there's something about the dwell time. So same story, when people actually end up spending more time, longer engagement and longer add to carts. I mean, this is, you would just say this is trivial. This is very obvious. Of course, the more items I put in my basket, the more time I have spent, et cetera, et cetera. But here was the catch. When we were talking with their head of design under chief product officer, one of the most important factors that they kept talking about was that how can we save them time? How can we create delight? How can we make this as quick as possible for them, right? And here we're like, at least your current system is definitely not moving you toward delight or toward at least getting, I shouldn't say that, but it doesn't move you toward like, getting things done fast. Here, a possibility of activation is like, what would it look like to create, if I know the routine journey of my loyal customers, maybe I create a basket for them that is already filled. maybe I have pre-filled baskets and carts ready for them, right? And they get notifications, hey, we notice you usually shop us on Monday, here it is, or like, but maybe even not something like that. Maybe when I open my app, my basket is already filled. And you just give me an option to remove some of the items that I don't want. That might be very quick, right? But anyway, so possibility of experimentation. I want to say 2 quick words about price sensitivity as well. As I mentioned before, there was definitely this belief that price matters. We didn't find practically any evidence for it. So this is, again, number of super departments on the y-axis, and this is price. Like literally horizontal, like just flat distribution, uniform distribution. This is number of unique add to carts, and again, dollar value of items to move. So across the x-axis, you have this uniform distribution. Here, as the diversity and number of super departments increase, now you see a little bit of price sensitivity coming like into the picture, but that's really about it. Of course, we looked at a lot of like other factors with time and price and all of those sort of things. Not much. We didn't find it significant. Experimentation, I feel like I've talked a lot about experimentation. I'm conscious of the time. I feel like the questions and discussions are actually very useful. But, you know, in terms of like the next steps moving toward the intelligent intervention piece, if we are extracting the risk, if we are understanding the relationships within the most important drivers of that risk within a session, then now maybe we can actually start, you know, thinking about experimentation a little bit more carefully, right? And then we can build these different hypotheses, come and test it, and then potentially feed it into another optimization engine. Yeah, I think the piece that I want to highlight is really this behavioral economic piece. Like, just let's not take what comes out of the models literally. Let's just, you know, ask a few questions, just challenge the things that we see, challenge some of the assumptions that we have. And if we do that more, if we get into the habit of that, the odds are actually business stakeholders are going to start listening to data scientists that much more as well. In terms of the intelligent intervention, the model, the optimization model, I'm not going to get too much into it. But one of the things that I want to say is that when you have a model that is a transformer, it's a complicated model, and somebody also asked about, you know, the timing and some of the feasibility questions. You don't really need to fire a model like this at every single action, at every single event that happens within a session. It can actually really be handled asynchronously, because the important thing is that somewhere in the session, I'm going to know if the session is going to end into purchase or if people are going to drop out. So if I have that information, everything else really comes after. What are different components? What can I do with discounts and promotions? What can I do with different kind of recommendation models that we have? In this particular case, they literally had 6 different recommendation models, like firing in every session. Like, do you really need that? The odds are, the answer is no. The last piece, this person comes from McKinsey. This is I find this really interesting because, you know, it really contrasts the business value and the feasibility considerations. These are all different use cases that are highlighted in retail, right? Prices, promotion, markdown. So we talked about discounts and stuff like that on pricing. Personalization, and in-a-store, on-shelf availability. So these are some of the 3 main things that really end up in this top corner, right? And it just kind of goes down from there. I think the most important piece in all of these discussions that we are having is we have to understand it to what end, and we have to figure out a way, a data-driven way, to find evidence to show that this thing actually is going to create value, or this other activity, the odds are not really. There's always I guess different considerations. There's always a trade-off. But like, if something is not going to scale, why bother? If something is going to scale but it's not going to create any value, why bother, right? So we really have to ask those hard questions from ourselves. And I think that's my last slide. I have some information about the neural net transformer, some additional information here as well. Happy to share this presentation later on. But I'm going to stop this and come back to main page.
Okay, thank you so much. It was really such an interesting presentation. I don't see any other questions, so people don't be shy. Ask other questions. Okay, questions are coming. So first, I think it's just a curiosity. How many people worked on this project?
On this project? Yeah, that's a good question. How many of us? I think it was about 5 of us working on it.
That's a pretty good team, 5.
So let me say one more thing about that. But the team was very diverse. We had 2 physicists, so 2 of them PhD in physics, 1 of them with another master's in big data. We have 2 other economists. One of them an econometrician, another one actually a public economist, but everything machine learning. And and then we had computer engineers. So the whole point of it is that you really want to come at it from different angles. Just it's at that intersection that all of these different ideas bubble up. Like I very clearly remember the day that we were talking about transformers, and we were like, no, that's going to be a waste of time. We won't be able to implement it. How about simpler XGBoost? But then we are going to, it's going to come at a cost of like losing information. So what do you do? What do you do there, right? So and we were like, maybe we can do both, and this is how it can actually manifest.
Yeah, that was really impressive, honestly. I never thought about using transformers in that way. So yeah, really impressive.
We've done it a couple of times. They're fun. They're really fun to work with.
Okay, we have 2 questions. So if you know that probability of risk completion is high or low, how do you suggest that data is used real time to personalize a session of the customer?
Yeah, that's a very good question. So one of the things that, for example, we just talked about was diversity and super departments, right? So if you know a session, like just around minute 3 in the session, you just know the probability is kind of dropping, meaning that the risk is high. Like that would be a moment that you would just, pop up a recommendation system can be actually fired at that moment, but with this sense of complementarity, because we know diversity matters, right? That would be one piece that real time, and it doesn't need to show up for every single person that does things like that. But just when the risk increases over a threshold, based on the drivers behind that risk, you can come up with that right thing. Sometimes it can be a recommendation model. One of the things that we actually saw was, although I talked about prices not being that important, but one thing that was important about price, if the price was not accurate, that definitely would just kill the session right there. And also number of out of stock options that also removed decrease the probability. So these were some of the things of like, how about we don't do anything complicated? Let's just show them the accurate price and do not show out of stock options. But then that's not necessarily the full picture, because is it better not to show the out of stock option overall, or is it better to let people know that we carry this, but right now we are out of option, or out of stock, but it's going to come back later, right? So it's just, it can go in a lot of different ways, hence experimentation.
Yeah, for sure, I do the same. If it's out of stock, I don't go and see. I remove that item from my cart, for sure.
Yeah.
Okay, we have a last question. Any recommended reading on behavioral economics for data science folk who are unfamiliar with the subject?
Yeah, there are a lot of really good books. One of them, so a couple of books that are very good books for behavioral economics. One of them is called Predictably Irrational. I can just type it down here as well. Predictably Irrational is one of them. The other one is called Misbehaving. These are written by economists. One of them is at MIT. The other one, I don't know where he is at. Misbehaving is also a really interesting one. There is one rather thick one. Depends how much people want to get into these sort of conversation, but it's on game theory and just a strategic thinking. But like I think the real power with people who are have the data mindset, as in we know the language, we speak the data language. The data language is not English, data language is math. We speak that language. But if you actually combine that with a very interesting, different discipline that is still used very much the same language, because in economics, the foundation of it is also math. Like those two are going to be extremely powerful. So anything that is related to these topics, but predictably irrational or anything else by the same author, misbehaving, these are really good books.
Thank you so much for the suggestion. I see coming in the chat link of those books. And I actually lost one question. So this is probably the last one, the real last one. You mentioned that you build custom models and solutions. Did your client look at existing insight tools such as a segment for Google Analytics?
Yeah, of course. This client has a lab filled with PhDs sitting in San Francisco. They have done a lot of work. Their personalization department is actually quite advanced. They had done a lot of really interesting work, but because they also have an army of data internally, they build a lot of things from scratch themselves. So they don't necessarily use a lot of these out-of-box tools. The complexity of data sometimes makes it a little bit prohibitive. Like, I understand there are use cases, and there are good use cases that you can use some of these out-of-box models. But again, if you don't really understand what goes into these models, the odds are you're not benefiting from, you're not really galvanizing on the maximum possibility and potential of this.
Thank you so much.
You're
so
welcome.
This presentation was so interesting. I cannot stop telling it. And we don't have any other questions. So
thank you so much for hosting me. This was fantastic. Questions were all great. And I hope that everybody find it useful. And please enjoy the rest of the conference. I know every speaker, there are incredible speakers lined up. So just good luck with everything.
Thank you so much for being here. Thank you so much. Thank you so much, everyone.
Bye.